Okay, so for 9.1, classifying and evaluating polynomials, we're going to classify a polynomial by its number of terms and its degree, and we're going to evaluate a polynomial using given values for the variable. So you guys said you already did this last year, so what do you know about polynomials? Okay, so give me a definition. What is a binomial or a monomial? Okay, what's a term? So what is it? But define a term for me. What's a term? 4x or 4y. Good. A term can have one number and any amount of variables. Okay. Anything else? Can have exponents. Okay. So you drop the term monomial and binomial. What's the difference? Okay, so a monomial is one term, a binomial is two terms, a trinomial is three terms. You said so on and so forth. Okay, so after that they are called polynomials after three. Okay, so how do you know the difference between a monomial and a binomial? Okay, so we separate terms by using an operation like plus, so addition, subtraction. Multiplication, is multiplication separate terms? I don't know. I mean, if you look at this monomial, it's 8 times a times b squared times c. So does multiplication separate a term? No. Okay, good. It's all just one term, yeah. So does division separate terms? No. So what separates terms? Addition and subtraction only. Good. So very nice. So you have just taken care of all of these definitions right here to trinomial. So how about the degree of a term? You got that one. Do you know how to do that? That's what I need to do. Like if we don't know if this is where we need to start, that's good. Like that helps. It's combining the exponent numbers. Okay, so you said in this one, so we have x to the power of 2, y didn't have anything, but it's always to a power of 1. So we add those up, 2 plus 1 equals 3, and so it has a degree of 3. Okay, so for the above one, we have a 3, a 2, and a 4, right? And so that gives us a degree of 9. 3 plus 2 is 5, 5 plus 4 is 9. That's exactly correct. Okay, that's how you find the degree of a term. You add the exponents of each variable to get the degree of a term. So then, how do you get the degree of a polynomial? Okay, it says the highest degree of any term. So you don't add them all together. Okay, you just pick the biggest one. You got it. So what's the degree of, so if we take the 3x squared y, what's the degree of that one? Okay, well, but to get the degree, we have to add up all the exponents. So it's going to be 2 plus, it's not 2 plus 3, the exponents. 2 plus 1, which equals 3. Okay, so that's my degree for that one. Okay, so let's look at 2x. What's my degree here? It has a degree of 1. All right, and 4x y squared. 3, because that's a 1 plus 2, right? So that's a 3. Okay, so it says state the degree of the polynomials. You did that. Or so we stated the degree of the polynomial. Did we do that? I should say. No. Why isn't there a 1 between the 4? So like 4 to the power of 1? Because we only, when we talk about the degree of a term, it's the sum of the exponents of a term's variables, never the constant, only the variables. That's why. But did we state the degree of the polynomial? No, we stated the degree of each term. So, Bailey, what was the definition of the degree of a polynomial? The highest degree of any term. So what's the degree of this polynomial? 3. Okay, so it's we would say it's a third degree polynomial. Okay, because the highest one we had was 3. Of all of them, yeah. If we had a 4, 3, and a 1, what would it be? It'd be a 4th degree. You got it. So we truly only pick the highest one. The term with the highest degree is what we call the polynomial. Good work. So see, you guys have a great memory there. All right, so how about standard form? Do you know about standard form of polynomials? Don't remember doing that. Okay, so in standard form, the terms are arranged in order, so arranged in order of descending degrees of one of the variables. So let's look at the example. We have 4x squared plus 3 plus x plus 6x cubed. This is not, okay, standard form. Kind of like scientific notation when we did, right? It had to be 1.7 times 10 to whatever, not 17. If we didn't have it in the right order, it wasn't scientific notation. Should be written as 6x cubed plus 4x squared plus x plus 3. What's the difference between the not standard form and the standard form?
Well, they combine. Well, they put your x is your variables are in front of your like numbers. So
okay, good.
3 needed to be at the end of all of them, and your one with the highest exponent needs to be in the first place.
Perfect.
So they put them in order of how they go. So it's like 3, 2, 1, 0 almost.
And that's what descending means. Okay, 3, 2, 1, and 0. I like it. Okay, because it's x cubed, x squared, x to the power of 1, and no x, right? The constant always goes at the end because there's no x value at all. Okay. If they're like x squared, y. You would combine them, right? We combine like terms. So it'd be if it was 3 plus 4, then you would change it to 7. Or if it was 3 minus 4, you change it to negative 1. But yeah, you should only ever have one constant. Good question. All right, nice explanation, Josie. Okay, so then if you look at each of these, okay, they have them classified a little bit, but we see that they're in descending order. Doesn't matter how many terms we have, we're going to put them with descending order with that constant number at the very end every time. Okay, next up, it says polynomials are evaluated by substituting the given values and following the order of operations. Haven't you done this before? Yeah, so is that anything really new? No? Okay, so Connor, how would we evaluate here? Okay, so write me the new expression. Yeah, so we just put the 3 in. Okay, so how would I solve it, Connor? Okay, so we have to do the exponent first, right? So we would have 2 times. Okay, great. Josie, what would you do next then? So we have 18
Oh, well, yes.
minus 15. Okay, she was ahead. That's okay.
That's gonna be like 3 plus 6. So then you get 8. No. Yeah.
Okay, so we have 9. Good. Yeah, evaluating them is not necessarily the hard part. All right, B looks a little more complicated, perhaps. So Bailey, can you evaluate B for us? Start us off. Well, then it would be 1 because it's Y, right? Good. Perfect.
Can you just get rid of the ones because they're all being multiplied and that doesn't change anything?
I was like, the ones aren't going to change anything. So that makes, I mean, I understand what you're saying there. Okay. Then Olivia, can you do the next step for us?
You need to do the exponents, so that's 5
Mhm.
times -8.
So this is 5 times the -8 times 1, right? Like, we don't even need to write it. Okay.
Plus 2 times.
Okay.
Or should I?
It doesn't matter to me. I personally go ahead and do it, like, but it doesn't matter to me if you do 2 times -2 or if you go ahead and put -4 in there. -4, okay.
Minus 3.
All right, great. Cheyenne, pick up there. Okay. Okay. Do you care if I just go ahead and write -4? Okay, so -4 minus 3 plus 5. All right. Chase. Okay, good. Awesome. That's it for today. So your first day of polynomials, right? We're just classifying and evaluating them. That is all. The chapters always start off with review and like, what do you know already? This is true. So it seems a lot easier. We're not learning new material usually on day 1.